I want you to look at these two plants. Same seed, same pot, same water, same sunshine, planted on the same day in the same corner of the same balcony. One of them looks like it's giving up on life. The other one is so full it's trying to escape the container. The only difference between them is this: a $1.97 bag from the garden store that most people walk straight past because it doesn't have a flashy label. No celebrity endorsement, no aggressive marketing, no promise of miracle results on the front. And I almost walked past it too until I started reading the actual science of why plants grow. And once I understood what was really happening underground, I realized that almost everything the fertilizer industry sells you is designed to make you dependent on them, not to actually fix the problem. In this video, I'm going to show you what that $2 fix actually is, exactly how it works at the soil level, how to use it correctly so you're not wasting your time, and why the $40, $60, and $80 bottles next to it are, in most cases, doing far less than you think. Stay with me because I'm going to explain this in a way that actually makes sense. No jargon, no guesswork, just the biology behind why some gardens thrive and most don't. Let me tell you what's actually going on when your plants aren't performing, because most gardeners are solving the wrong problem. When your vegetables are small, slow, pale, or just limping along, the first thing people do is reach for fertilizer. More nutrients, more feeding, more input. And I get it. It makes intuitive sense. Plants need nutrients to grow, so more nutrients means more growth, right? Wrong. Here's the thing that nobody in the fertilizer aisle is going to tell you. Plants don't absorb nutrients directly from the soil the way most people imagine. It's not like a plant is just sitting there with a straw sipping up nitrogen and phosphorus from the ground whenever it feels like it. The way plants actually get their nutrition is through a partnership, a biological deal they've been running with soil, microorganisms for hundreds of millions of years. Healthy soil is not dirt. Healthy soil is a living ecosystem. There are billions, and I mean that literally billions, docs, of bacteria, fungi, and other microorganisms in just a single teaspoon of good garden soil. These organisms break down organic matter into the exact forms of nutrients that plant roots can actually absorb. They process the raw materials into a bioavailable meal that gets delivered directly to the root zone. When those organisms are thriving, your plants get fed constantly, efficiently, and in exactly the right amounts. When those organisms are depleted, which is the state of most bagged potting soil and most over-fertilized garden beds, your plants are on their own. And no matter how much fertilizer you pour on top, if the biology isn't there to process it and deliver it, your plants can't use it. A study published in the Journal of Plant Nutrition found that conventional synthetic fertilizers have an average uptake efficiency of around 30 to 50%. That means in the best case scenario, your plant is only actually using half of what you're applying. The rest leaches out, locks up in the soil chemistry, or runs off entirely. You're not growing a garden, you're pouring money through a pot and into the ground. So what depletes the soil biology in the first place? 3 things. And if you're a typical home gardener, you're probably doing all 3. Number 1, synthetic fertilizer overuse. High concentration synthetic fertilizers are essentially salt-based compounds. When you apply too much, the salt concentration in the soil rises, and it becomes hostile to the microorganisms that live there. You're killing your own soil army while trying to feed your plants. Number 2, bagged potting mix from the store. Most commercial potting mixes are made from peat moss, perlite, and a slow-release fertilizer pellet. They're essentially sterile growing media, clean, consistent, but biologically dead. There's almost no microbial life in them when you open the bag. Number 3, overwatering. Beneficial soil bacteria and fungi need a balance of moisture and oxygen to thrive. When soil stays waterlogged, you create anaerobic conditions, low oxygen, which kills off the aerobic organisms you want and encourages the wrong kind of microbial activity. Most struggling gardens have all 3 of these working against them simultaneously. So what does the $2 fix actually address? It addresses the root cause, the biology, instead of throwing more nutrients at a system that can't use them. The $2 fix is worm castings, also called vermicompost, also called worm humus, worm manure, or, if you want to sound like a soil scientist at a dinner party, vermicast. And before you click away thinking, yeah, I've heard of worm castings, that's not new information, I want you to stick with me for a minute. Because what I'm going to tell you isn't the usual surface level gardening tip. I want to explain exactly what is inside a worm casting and why it creates effects in your soil that fertilizer chemically cannot replicate. When an earthworm processes organic matter through its digestive system, something remarkable happens. The material that comes out the other end is not just broken down plant matter, it's been transformed. Let me walk you through what's actually in a handful of worm castings. First, microbial density. Worm castings contain somewhere between 100 million and 1 billion colony-forming units of beneficial bacteria per gram. Per gram. That is a level of microbial life that no synthetic fertilizer can give you, because synthetic fertilizers contain 0 living organisms. When you mix even a small amount of worm castings into your soil, you're not just adding nutrients. You're inoculating the soil with a population of beneficial microorganisms that immediately go to work processing the organic matter already in your soil and making nutrients available to your plant roots. Second, plant growth hormones. Worm castings contain naturally occurring plant hormones, specifically auxins and cytokinins, which directly stimulate root growth and cell division in plants. This is why plants grown with worm castings tend to have larger, more extensive root systems, which means better water uptake, better nutrient absorption, and more drought tolerance. No standard fertilizer contains these hormones. You cannot buy this effect in an $80 bottle. Third, humic acid. This is the compound that I think is the single most underrated thing in gardening. Humic acid is produced when organic matter fully decomposes and it acts as a chelating agent. It binds to nutrients in the soil and holds them in forms that plant roots can actually absorb, instead of letting them leach away or lock up. Think of humic acid as the delivery infrastructure for your soil's nutrition. Without it, nutrients are present but inaccessible, like food locked inside a cupboard with no key. With humic acid, the cupboard is open. Fourth, water retention improvement. The texture of worm castings is uniquely granular. Each casting is a tiny pellet that improves soil structure and water retention. Studies have shown that adding worm castings to sandy or peat-based soils can increase water retention by up to 30%, which means less frequent watering and less stress on your plants during heat spells. Fifth, natural pest and disease suppression. This one surprised me when I first read it. Research from Ohio State University's Soil Ecology Laboratory found that worm castings contain enzymes and microbial compounds that actively suppress certain soil-borne fungal pathogens, including Pythium and Fusarium, two of the most common causes of root rot and seedling damping off in container gardens. There is no synthetic fertilizer that gives you this. You'd have to buy a separate fungicide for that. And even then, you'd be treating the symptom, not building the system that prevents the problem. Now, here's where the comparison gets uncomfortable for the fertilizer industry. A 4-liter bag of a leading brand liquid fertilizer, the kind sold in every garden center, costs around $18 to $25 and is essentially a concentrated solution of nitrogen, phosphorus, potassium, and sometimes a few micronutrients. It dissolves quickly in water, delivers a short burst of nutrients, and then it's gone. The next week, your plant needs another dose. A 1-liter bag of worm castings costs $1.50 to $2.50. You mix it into your soil once. The microbial population establishes itself and keeps working for months. The humic acid stays in the soil. The water retention improvement is structural and ongoing. The root hormone effect happens during the most critical growth phase. One is a meal. The other is a digestive system. And once you understand that framing, you'll never look at the fertilizer aisle the same way again. I want to address the obvious question here. Is this actually backed by evidence, or is it just gardening folklore? Because there's a lot of folklore in gardening. A lot of home remedies, and my grandmother swore by this advice that doesn't actually hold up when you test it properly. Worm castings are one of the most studied soil amendments in agricultural science. This isn't fringe knowledge. This is mainstream agronomy. A study published in Bioresource Technology followed tomato plants grown in 3 conditions: standard potting mix with no amendments, standard potting mix with synthetic fertilizer applied at label rates, and standard potting mix amended with 20% worm castings with no additional fertilizer. The results after 8 weeks: the worm casting group produced plants with 58% greater shoot dry weight, 40% more root biomass, and earlier flower set compared to both the control and the synthetic fertilizer group. The synthetic fertilizer plants performed better than the control, but significantly worse than the castings group. Now, 20% by volume might sound like a lot. In practice, for a standard 10-liter container pot, that's 2 liters of castings mixed in at planting time. In most garden stores, 2 liters of worm castings cost between $3 and $5. The tomato plant in that pot, at current vegetable prices, will produce well in excess of that value if grown to its potential. A separate trial by researchers at Tuskegee University looked at pepper yields in container gardens. The worm casting amendment group produced 35% more fruit by weight compared to the standard fertilizer group with no additional inputs, just the castings mixed in at the start. I also want to share something from my own experience testing this. I set up 3 identical containers, same plastic pots, same dimensions, same seed variety, same watering schedule, same sunlight exposure. Container 1, standard bagged potting mix, no amendments. Container 2, standard potting mix plus a weekly dose of a popular liquid fertilizer at label rates. Container 3, standard potting mix with 20% worm castings mixed in at planting, nothing else added. By week 4, container 3 had noticeably deeper green leaf color and more compact, vigorous growth. By week 8, the yield difference was clear. Container 3 outproduced container 2 by roughly a third. The fertilizer container wasn't bad, but the castings container was simply operating on a different level, which brings us back to those 2 plants at the start of this video. The struggling one is in standard potting mix with a slow-release synthetic fertilizer pellet mixed in, exactly what the bag from the store recommends. The thriving one is in the same potting mix with 20% worm castings substituted in at planting. Same everything else. Now let me walk you through exactly how to use worm castings so you get the full benefit, because there are right ways and less effective ways to do this, and a few common mistakes that will reduce your results. Method 1. Mix into potting soil at planting time. This is the most effective application and the one that gives you the best long-term return. When you're filling a new container or repotting a plant, aim to incorporate worm castings at a rate of 10 to 20% of your total soil volume. For a standard 10-liter pot, 1 to 2 liters of worm castings mixed thoroughly through the soil before you plant. For a 5-liter pot, half a liter to 1 liter. You don't need to be precise to the milliliter. More is fine. Worm castings cannot burn roots or over-fertilize. Unlike synthetic fertilizers, there is no toxic dose. Mix them in thoroughly rather than layering. You want the microbial inoculation distributed throughout the root zone, not concentrated in one band. Method 2. Top dressing for existing plants. If you have plants already in containers that are struggling, you can top dress them with worm castings as a revival treatment. Pull back the top inch or 2 of soil carefully without disturbing the roots. Spread a 1 to 2 centimeter layer of worm castings across the soil surface. Work it gently into the top layer of soil. Water normally. This won't have the same root contact density as mixing in at planting, but it allows the microbial population and humic acids to work their way down through the soil profile with each watering. Most gardeners see results within 3 to 4 weeks. Method 3. Worm casting tea. This is a liquid application method that some gardeners prefer for established plants, especially in larger containers where mixing in would be disruptive. You don't need any special equipment. Take a clean bucket or watering can. Fill it with water, ideally rainwater or water that's been left out overnight if you're on chlorinated main supply, because chlorine can reduce microbial viability. Add a handful of worm castings, roughly 200 to 300 grams per 10 liters of water. Stir vigorously. Let it sit for 30 to 60 minutes, stirring occasionally. Then water your plants with it directly, trying to get it to the root zone rather than just the surface. The liquid acts as a microbial drench. It delivers a concentrated population of beneficial organisms directly to the root zone. Frequency and ongoing use. Here's one of the key advantages over synthetic fertilizers. You don't need to apply worm castings every week. Because you're building a biological system rather than just delivering a chemical dose, the effects are cumulative and self-sustaining. For a container garden, mix in at planting, top dress once at the start of peak growing season, and that's typically sufficient for one season. If you're growing in the same containers year after year, which I'd strongly recommend avoiding, because pathogens accumulate in reused container soil. A fresh mix with worm castings each season resets the biology. What to look for when buying. Not all worm castings are created equal, and this is worth spending 60 seconds on, because there is some genuinely low-quality product on the market. Good worm castings should be dark brown to black, have an earthy smell, clean, not unpleasant, and have a fine granular texture with no visible uncomposted material. They should feel moist, but not wet. Avoid products that smell strongly of ammonia, indicates incomplete composting, are very dry and dusty, microbial population has died off, or contain large amounts of undecomposed fibrous material. The cheapest bags on the shelf are sometimes diluted with peat moss or other fillers. Check the label. It should say 100% vermicast or worm castings with no additional ingredients. For most home gardeners buying from a local garden center, a 1 to 2 liter bag will be more than enough for several pots of vegetables. At $1.50 to $2.50, you are looking at a per pot cost of well under $1 in many cases. Now, I want to be fair here because I said earlier that the expensive stuff is in many cases a scam. And I stand by that in the context of it being used as the primary or sole soil strategy. But I want to be precise about where fertilizer does earn its keep. Because I'm not trying to sell you a simplistic, chemicals bad, natural good narrative. That's not science either. Liquid fertilizers genuinely help in 3 specific situations. Situation 1, fast turnaround crops in already healthy soil. If you're growing salad greens or radishes on a short cycle, 30 to 45 days, in soil that already has a functioning biology, a low-dose liquid fertilizer top-up around mid-cycle can genuinely boost yield. The biology is there to process it efficiently, and the short growth window means you're pushing for maximum production speed. Situation 2, post-transplant recovery. When you transplant a seedling, it goes into transplant shock, root disruption, adjustment to new conditions. A dilute liquid fertilizer applied in the first week after transplanting gives the plant easily accessible nutrition while it's reestablishing its root system and before the soil biology has had time to fully engage. Situation 3, deficiency correction. Deficiency? If you've done a soil test, which I'd highly recommend, and I'll cover that in a separate video, and you have a confirmed specific deficiency, say calcium deficiency causing blossom end rot in tomatoes, or iron deficiency causing intervenal chlorosis in your leaves, a targeted supplement to address that specific deficiency makes sense. But you need to know what the deficiency is first. Blanket applying expensive complete fertilizers in the hope of hitting whatever's missing is expensive guesswork. The issue with how most home gardeners use fertilizer is that they use it as a substitute for soil health rather than as a supplement to it. They're trying to force feed a broken system instead of fixing the system. And the reason the industry doesn't tell you to fix the system is that a healthy soil biology dramatically reduces how much fertilizer you need to buy. A functioning microbial ecosystem in your container will recycle nutrients from organic matter, fix atmospheric nitrogen if you have the right organisms present, and suppress disease naturally. Once you build that system, your input costs drop significantly and your yields go up. That's not a great business model for the fertilizer companies, but it's a great outcome for you. Here's where this gets even more interesting for anyone who wants to go deeper. You don't actually have to buy worm castings at all after the first season. Vermicomposting, keeping a small worm bin at home, is something you can set up for under $20 if you buy a basic plastic bin and drill a few holes, or for free if you have a spare container already. Red wiggler worms, the species used for vermicomposting seeds, can be bought online for a few dollars for a starter population, or obtained for free from someone who already has a bin, because worm populations expand fast and keepers are often giving away excess. What you feed it: vegetable scraps, fruit peel, coffee grounds and filters, tea bags, cardboard torn into small pieces. That's it. No meat, no dairy, no cooked food. The bin doesn't smell if managed correctly. Aerobic decomposition with a functioning worm population produces that clean, earthy smell, not an unpleasant odor. A correctly managed bin can sit on a balcony or in a kitchen without any issues. What you get out? Within 3 to 4 months of starting, you'll begin harvesting castings from the bottom of the bin. Depending on the size of your worm population and how much organic waste you're putting in, a small bin can produce several liters of castings per month. More than enough for a balcony container garden. The economics of this are almost absurdly good. The inputs are kitchen waste you're already producing. The outputs are the highest quality soil amendment available. Your ongoing cost is essentially zero. And there's a feedback loop here that I find genuinely satisfying. The vegetables you grow feed you. The scraps from those vegetables feed the worms. The worms produce castings. The castings feed the next round of vegetables. You've created a closed system out of what was previously waste going into a landfill. That's not just cheaper than buying fertilizer. That's fundamentally different from how most people think about growing food. I want to step back for a moment and talk about why I think this stuff matters beyond just getting bigger tomatoes. Most of the information in the gardening space, including a lot of what gets sold to beginners, is based on managing symptoms. Your plant is pale, add nitrogen. Your plant is dropping leaves, add phosphorus. Your fruits are small, add potassium. Every problem has a product attached to it. And when the products don't fully work, when you spend $40 on fertilizer and your yield is still disappointing, the conclusion most people reach is that they just aren't good at gardening, that growing food is complicated, that it requires more expertise or more money than they have. That conclusion is wrong, but it's profitable for the people selling the products. The actual reason most beginning gardeners struggle is that nobody ever explained to them that the soil is alive, and that if you care for the life in the soil cares for your plants. Once you understand that, once you stop trying to manage your plants and start trying to build the environment your plants want, everything gets easier. The watering is more forgiving because the soil holds moisture better. The feeding is more consistent because the biology keeps working even when you forget. The disease pressure is lower because a thriving microbial ecosystem outcompetes pathogens. Those two plants at the beginning of this video aren't the result of skill. They're the result of understanding. The $2 fix works not because it's magic, but because it's working with the biology of the soil instead of against it. And once you see that, you start to realize how many of the expensive products on the market are working against the biology and depleting it, bypassing it, or simply failing to engage with it at all. So, the $2 fix is worm castings. You now know exactly what's in them, why they work, how to use them, and why the expensive alternatives are mostly treating the wrong problem. Here's what I'd suggest you do next. If you have any plants currently in containers that are underperforming, try the top dressing method I showed you. Pull back the top layer, work in a centimeter of castings, water normally, give it 4 weeks. You'll see the difference. If you're starting a new container from scratch, mix in 15 to 20% castings at planting and watch what happens. And if you want to go further, if you want to understand what a soil test actually tells you about your growing conditions and how to build on the biology foundation we covered today, that's the next video. I'll show you exactly what to test for, how to read the results, and the 3 cheapest amendments that fix the most common deficiencies gardeners find. Most people are guessing about their soil. After that video, you won't be. I'll see you there.